I need to start the recording. Let's start this discussion about where this function is differentiable by asking the question, where is this function defined? All right?
Everywhere except for 1.
Okay, Ian?
Oh, it's everywhere where 1 plus x squared is greater than 2.
Okay, let's start with that idea. Okay, this function is only defined where the square root, where the thing underneath the square root is positive. By the way, the special name for that thing under a square root, it's called a radicand. Okay, the stuff under a radical sign is called a radicand. And so I start with that idea, and then I'm going to get caught up to where Ian is. Okay, when is that thing positive? Well, the bottom is always positive. So the only question then is, when is this numerator positive? Sorry, greater than or equal to. Well, x, I'll bring that negative x over, whenever x is less than or equal to 1. So the domain of that function is right there. Now that's one group of numbers that it may be differentiable on. I'm not saying it's differentiable on all those numbers. I'm saying that it could be differentiable on all those numbers. Continuity is the first step to determining differentiability. Now, let's handle this problem from the derivative side. dy dx is equal to 1/2. Keep the inside the same. Reduce the power by 1. And now I got to do the quotient rule for my chain. So bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared.
Great.
That's ugly. But let's not let its ugliness get in the way of doing this problem. So 1/2 times the square root of 1 plus x squared over x minus 1. Are you okay with that?
Yeah.
So it's the square root because it's a half. And you have the reciprocal because it was a negative. Okay? Next step here, let's see, let's distribute this negative 1 through, and I get negative 1 minus x squared. Let's take this negative and this 2x through, and I get negative 2x plus 2x squared. Did I do that right? Negative and a negative give me a positive 2x squared. I think I'm okay there. And this is all over 1 plus x squared squared. Cleaning this up, I got a 1/2. I've got the 1 plus x squared over 1 minus x. And I've got 2x squared. No, not 2x squared, just 1x squared. Because there's a negative x there, 2x squared there. X squared minus 2x all over. Now, here? We good then? All right, so our last question on this is then, looking at that derivative, are there any values of x that would make it so the derivative doesn't exist? And the answer is coming from right there. If x is equal to 1, this derivative won't exist. So we had started out with the domain was x is got to be less than 1. Okay, that's where the domain is, but we have to take away x equal 1. Is where it's differentiable. All right, so that handles number 33. I'll get the rest of these posted later on. Charlie.